think from what I can see in the list, most people it will be morning. Um, Thank you for that warm welcome. I'd like to thank FAO for the chance to talk today, particularly Emma Subarats, who asked me to do this, and Kana, who has been very helpful. So today I'm going to introduce RIOXX, talk a little bit about RIOXX itself, and then I want to talk a little about some of the techniques which we used to develop it. But before we get on to RIOXX, I think it's worth having a very quick introduction to the idea of a metadata application profile. Now, it may be that everybody on this webinar has some idea what a metadata application profile is, but I'm just going to very quickly introduce it in case there are people who are not familiar with this concept. So this is, I think, the best definition and one of the earliest definitions from Rachel Heery and Manjula Patel some years ago, which essentially describes application profiles as a collection of data elements from more than one namespace, typically, which have been combined in some way with some constraints added to optimize them for a particular application. And this is an important concept. It allows us to make use of information standards, which often have a fairly general application, and to focus them on a particular application space or a particular problem space. I think it's also worth pointing out that the development of an application profile can be quite different to the development of a standard, mainly because of the scale involved and the time scales involved, but also it can involve actually a different range of people. So it's my contention that there are different types of application profile, clearly, and I tend to put them onto this sort of spectrum where we have application profiles which have been developed to provide a range of interoperability solutions in a general domain space. Those types of application profiles would be on the left-hand side of my spectrum, on the left-hand side of that red arrow, where they're more constrained than a general standard. For example, Dublin Core is a standard that we're all familiar with. But where the application profile is not particularly focused on one use case or one problem space. It's designed to provide general interoperability. Some of you may be familiar with OpenAir, and I think OpenAir provides a set of application profiles which are somewhere in that region. They're designed to serve a particular domain, but without necessarily being tied to a particular use case. Then on the right-hand side of the arrow, we have, at the other end of the spectrum, we have application profiles which are deliberately very tightly focused to solving a particular problem or to serving a particular use case. So they will be very specific. Typically, they'll be quite small, very constrained. And RIOXX, which I'll be talking about, very much belongs at that end of the spectrum on the right-hand side there. So to come on to the RIOXX application profile itself, well, first of all, why did we bother? Essentially, RIOXX was conceived and development was begun in response to the introduction of some new policies from Research Councils UK and the Higher Education Funding Council for England in the UK, who fund a large proportion of the publicly funded research which is funded in the United Kingdom. And RCUK introduced a mandate that any journal article funded by research grants from the research councils in the UK must be made publicly accessible in a repository within a certain time period. HEFCE, the Higher Education Funding Council of England, is expecting to adopt a similar policy and to use RIOXX to effect that. At the time when we started working on this, the available metadata formats just weren't adequate to that task. OAI-DC, which is the default metadata format which is emitted by our institutional repositories through the OAI PMH protocol, just isn't constrained or rich enough, really. And OpenAir, which is much better than that, unfortunately had a particular requirement for the encoding of project IDs or grant IDs, which was actually incompatible with the way that the UK research councils form their what they call their project IDs. So almost solely for that reason, we were unable to use OpenAir out of the box, which meant that it was worth considering building something new and optimizing very closely for this use case. So RIOXX itself is, I think it's a classic application profile in the sense that it adds constraints to existing terms and adds a few new terms which were necessary, but largely it's trying to build on previous work and on previous standards. So it uses properties from Dublin Core, from NISO's open access metadata and indicators, which is a new namespace which has been introduced in the last 2 years. And we created 8 new terms in a new namespace, which we call RIOXX terms. So just to emphasize this point, it has one purpose, RIOXX, which is to provide this mechanism to help repositories report on open access outputs to research funders. And it's very definitely not designed to provide general interoperability. I think it's worth noting that RIOXX was born at UConn, sadly no longer in existence, developed by EDINA and myself working with a consultant called Sheridan Brown from Chigrove Limited, and supported by HEFKI and RCUK, and funded initially by JISC also. And version 2 was released this year. So what we've actually produced is the metadata application profile itself with the technical documentation which goes with that. And it's worth having a look on the website at the way we've tried to document it. We've had quite a lot of positive feedback from implementers who've said that our documentation is really helpful and clear, and that's an important thing, something that we actually put a lot of effort into and focused on. So I'm very pleased that the feedback is positive there. We've produced the XML schema because XML is the mechanism by which information is moved around between repositories and other systems typically. We've produced a mapping to OpenAir 3, working with people at OpenAir, some guidelines, a supporting website, and something which I'll talk a bit more about in a minute, a testing framework for implementations of RIOXX. And this is something which I think is quite innovative and quite new. I've not really seen anyone else do this. So I will talk a bit more about that in a moment. It's also worth pointing out there are other people developing software plugins to support RIOXX now, which is not something that we're directly involved in. They're just using our technical documentation in order to do that, although we do occasionally get calls and emails from those people to answer particular questions. But essentially it's independent of our efforts, and so there is what we might call a sort of growing ecosystem of software development around RIOXX, which is very encouraging. So the particular concerns in RIOXX were how to represent the funder and the project or grant that funder funds. There was a very significant effort to try to standardize around vocabularies to characterize the nature of the open access outputs, and there was a long consultation process between a number of organizations, including the commercial publishers, which was called Vocabularies for Open Access. A lot of people participated in that, and one of the recommendations from that process was to adopt the NISO open access metadata and indicators properties or terms and namespace, and so that's what we've done. We had to figure out how to represent the persistent identifier of the item described. That sounds straightforward, but actually isn't particularly straightforward. Repositories actually are quite often ambiguous about what it is that the metadata record is describing. There was an interest in providing identifiers to point to related artifacts, particularly things like research data sets which underpin the journal article. And then, very importantly, how to represent the rights of use. And this is an ongoing problem. I don't think we've solved it. I think we've helped to take a step in the right direction, but I think there's still a lot of work needed to be done there, clearly. So I'm going to quickly talk about some of the specific properties which relate to those concerns. So firstly, we use the DC identifier property. So this is straight out of the Dublin Core terms. We use it to identify the item, the actual open access item, which is identified by the metadata record. It's important to understand that this is not the published paper, or what we might call the version of record. This is the PDF typically which has been stored on the repository, so it's the open access item. The recommendation is to identify the resource itself and not a web page which contains metadata about that item, which is again a fairly common approach in repositories and which is very unhelpful for particularly for systems which are automating the discovery and access to papers, for example. Very importantly, whatever it identifies, it must be an HTTP URI. Now, this is something which I'm very pleased that we did, and I think it's been the impact of this will be quite considerable. So, rather than restricting, constraining the types of things which can be identified, what we've said is that they just simply, the identifier must be an HTTP URI. And that means that we can identify often the scheme that's being used from the URI. And this becomes important not just with the DC identifier property, but also, as we'll see later on, when we're using HTTP URIs as identifiers for people and organizations. It's one of those sort of compromises that you make in these kinds of activities where by insisting on an HTTP URI, we gain a lot of possible benefit, but without constraining the application profile too much. And there's an example there of the use of that property in an XML form. So a couple of other terms where we had to be careful, I guess, in figuring out how to represent them. So I said earlier that the DC identifier points to the repository item rather than to the published article. And so we also include a property where the again, the HTTP URI pointing to the actual published version of that paper can be entered as a value in that property. So often that will be a DOI actually represented in its HTTP form. And DC relation, which is a property which can contain multiple values, is the place to, again, put HTTP URIs which identify related resources. We decided to do nothing about attempting to characterize those resources That was outside of the requirement of the use case that we were solving, but having some place to at least link to those resources was considered to be desirable by the sponsors, so that's what we've done there. Again, reusing terms from Dublin Core. DC terms date accepted. The accepted date turns out to be a very important date in this use case, in many ways much more important than the published date, and actually a more clearly identified date than published. Just trying to define what's meant by the publication date for a journal article is actually quite an interesting challenge. There are many candidate dates for the published date, but the date accepted tends to be a more concrete business event. There's a contractual aspect to this, so it tends to be clearer and more precise. And the policies from the research funders which we're trying to support are actually based around the accepted date. So this is a very important property in the profile. RIOXX terms author and contributor, which have the same form. We were keen to start to introduce the use of global persistent identifiers for people, or parties, I should say, where parties are people or organizations. We're strongly recommending the use of ORCID. It's still not mandatory, it's an optional thing because ORCID is still not, sorry, the use of global persistent identifiers for people is not ubiquitous yet, but we're trying to encourage the take-up. Again, the requirement is that if a global identifier is provided, then it is an HTTP URI. It doesn't have to be ORCID, but if it is ORCID, then it will be readily identifiable as such from the domain name used in the HTTP URI. So this gives us that sort of ability again to encourage good practice without being too constraining. And there's an example of use of RIOXX terms author there. And the other one, which was the other property, which was took some time to work out, was the way of relating funders and projects and project IDs together. And we had very much tried to keep RIOXX as a simple, fairly flat structure, and this was one of the few exceptions where we had a slightly more complex property structure, but as you can see, it's not particularly complex. Where a given paper will be the output of a particular project which has one or more funders associated with it, and that's the form that's given there. We've strongly recommended the use of the International Standard Name Identifier ISNIs for particularly for organisations, given that ORCID is becoming the sort of de facto standard for identifying authors. And license ref we've adopted straight from the NISO, this new NISO standard for access metadata indicators, which takes that form. The recommendation I made to the research councils was that they should create a whitelist of acceptable licenses, and then all RIOXX needs to do is to indicate the license URI which has been applied to a given paper. There is an awful lot of work to do to gradually establish some sanity around the way in which publishers apply licenses and so on, and that's going to take years, I think, frankly. But nonetheless, there is a mechanism here now to capture that information, and again, it's structured and the recommendations, I think, follow good practice, but they're not too constraining. We're not trying to second guess exactly how this is going to be done in future, but we have a property there which allows for that kind of information to be captured. And lastly, it's worth a quick mention that we worked closely with people in OpenAir to produce a mapping It's a bit of it's a one-way mapping really. It's a way of mapping from RIOXX to OpenAir. We haven't provided a mapping in the other direction. I don't think that would be possible. But actually, this was the requirement. It means that if repositories in the UK have encoded metadata in correctly in valid RIOXX, then OpenAir can get the benefit of that through a simple crosswalk, metadata crosswalk, or mapping exercise across to OpenAir 3. So I want to talk a little about the principles of development. And I think the thing I want to emphasize is that at the very beginning of this and throughout the development of this profile, we were focused on implementation. There have been attempts to build application profiles to describe for metadata in this kind of general problem space, and they have not been implemented at all in the past. They've ended up being essentially an academic exercise with no take up. What we were determined about with this was that it would be implemented, and that implementation was the only measure of success. So for that reason, we, as I'll come on to talk about, we started to look at how we might develop this application profile in a slightly different way to improve our chances of it being implemented by essentially systems people, people who are going to be building plugins for repositories and other systems which will be consuming data from repositories. So one thing we decided to do was to look at what we could learn from software developers. And I've reproduced here the something which some of you may have seen before, the Agile Manifesto. So I'm sure everybody would have heard the term Agile used often describing development processes, particularly in software development. It's a very overloaded term now, and which is unfortunate, really. But this is really where it started. I discovered I hadn't realised quite how old this is now. This is 14 years old. This manifesto. But the manifesto essentially, well, it says what it says. It's saying that we are going to emphasise certain things. So individuals and interactions rather than processes. Working software is the first measure of success, much more important than the comprehensive documentation. Customer collaboration rather than contracts. So this is a definite sort of challenge to previous methods of software development where you would work out a very detailed specification before you started. With Agile, the idea is that you work with people and that you expect the requirements to change over time. And responding to that change is really key. So we looked at how we might apply some of these principles to the development of RIOXX, and I think we can apply pretty much all of them. The one thing where I've put a red X there is the idea of working software over comprehensive documentation. Well, I mean, on the one hand, an implementation in software is the only measure of real success, even for a metadata profile, in my view. But we have to accept that the actual development work for RIOXX is to produce a set of technical documentation. I mean, that's the output for a metadata profile development project. So, but apart from that, I think we can see that we can and we were able to apply these principles to the development of RIOXX. And there are a number of particular techniques which we did adopt. I'm not going to talk about all of them because we don't have time this morning. I'll just run through this list very quickly, but the one I really want to talk about is testing. So, but from the top, first of all, there's this notion of iterative design, and there are some branches of agile development of software where the iterative design is the iterations are optimized to take only 2 weeks. You have a 2-week sprint, develop some software, and then you have a review, and then you have another 2-week sprint, and so on. I think with developing a metadata profile, those sprints actually will likely be a bit longer than 2 weeks. But I think with RIOXX, we more or less got it to about 2 months. We would go working in 2-month iterations where we would do some development, test it, get some feedback, get some public feedback, and then go back to the sponsors and have another session where we discussed what we had learned and what we had developed so far. And then we would plan another period of development. And that actually worked. And I think that documentation can be made that way just as readily as software code. Another principle is this starting with the minimum viable product, the MVP. So from the beginning, you want to get something which is workable as early as you possibly can. And I think that principle can also be applied to data application profile development. And I think that's what we did. But the one I really want to talk about is testing. And this is a relatively new idea in software development. Probably in the last decade it's become mainstream. But this is the idea that you don't build the software for over a long period of time and then test it, but that you're testing it as you're building it, and you're adding more and more tests as you're building it. And there's an extra aspect to this which I'll talk about, which is testing openly, doing so in a very open way so that everybody can see the results of the testing. It helps everybody to understand what's going on. So it's really important. If you're going to be doing a lot of testing, then you really want it to be done efficiently. So you want it to be automated where possible. And certainly it should be mechanistic. It shouldn't be ad hoc. It's no good just saying every 2 weeks we're going to have a look at this thing and discuss it. It actually needs to be something that can be left to run by itself to some extent. And it has to go beyond XML schema validation, which is the sort of default level of testing that we have certainly for XML-based metadata profiles. I mean, that's useful and important. That kind of validation is important, but it's not enough. And the reason it's not enough is that typically all you get from that kind of testing is a result of success or failure, and you don't get a lot of other information. So what we've been doing is we have identified the repositories in the UK which advertise support for RIOXX. And this is an automated process. We can go to the registry of repositories run at Nottingham University called OpenDoor, and we can automatically query that for a list of repositories which claim to support RIOXX. And we can automatically go to each of those repositories and harvest a sample of records and then test those thoroughly. And the outputs of that are on the RIOXX website, and you can see a screenshot of that page here. So it says 21 repositories. Actually, as of this morning, there are 26, so it's steadily growing. And you can see that for basic RIOXX validation, we've got a couple which have hit 100%, so they're perfect in that set against that test, and then a number which are 90% and all the way down to 10%. For full RCUK compliance, where the test is stricter and introduces more constraints, we've got 0 compliance at the moment. And that's largely because of things like people are not yet supplying the correct license information, for example, things which we know are going to be problematic. So of those 2 tests, the 2 columns, basic RIOXX and full RCUK, the one on the left is broadly testing syntax. It's testing that the records are syntactically correct, whereas the one on the right is testing all kinds of other things, like the existence of particular vocabularies and so on. But this gives a picture of the level of compliance that has been achieved so far, and is very useful. And if I go on to the next slide, you can see this is go back, sorry, clicking on the right-hand side, clicking on one of those report links for any of these repositories gives you this output. which is explaining precisely where that test may have failed for a particular record, and even showing you in the XML source that we harvested from that repository, showing you where those things occur. So this is giving a lot of real feedback to the implementers of the software on that particular system, showing them exactly where their implementation is succeeding or failing. It's also giving information to repository managers. It may be that the software is fine, but that the administrator of that system is putting incorrect information into the system. So both of those audiences can get some value from this testing output. And then finally, this is a work in progress, but we're starting to characterize the implementation of RIOXX across the aggregate of all of the known implementations. So this is starting to give us, the developers, some feedback about which aspects of RIOXX are causing problems for people. So here we can see that, for example, that license ref has a lot of issues, and generally it's failing because there are too few values. And I think if we drill down into that, we'll discover it's because the license ref just hasn't been actually included. And we can see that there are other problems there with people entering dates incorrectly. There's a fairly strict requirement for an ISO 8601 formatted date, for example. I'm planning to do a little more development on this to give people richer feedback, but that's the sort of thing that we do. So to summarise, RIOXX has been created to serve this use case of open access reporting. We've used a bunch of more agile approaches and techniques, and I could talk more about that if I had time, and largely borrowed those from software development. We know about 26 repositories that have implemented it so far. There are several other systems which have contacted me about using RIOXX in one form or another. There is interest in RIOXX, interestingly, as a general interoperability metadata profile for this general space, even though I'm very clear to point out to people that that's not what it was developed to be. But nonetheless, if people find it useful, then that's fine. And adoption is growing steadily, I'm pleased to say. So thank you very much for listening, and